Let me give you a brief introduction to hyperbolic functions. So starting with hyperbolic cosine. So hyperbolic cosine, we still write cosine, but we add an h after the cosine. The h stands for hyperbolic function. Hyperbolic cosine of x. So before we go into that, I won't waste any time to try to pronounce the cosh. So when you express hyperbolic cosine, just say hyperbolic cosine. So and then when you write, you just write cosine hx. So that is the sum of half of e to the x plus half of e to the negative x, and then usually the book will just write e to the x plus e to the negative x divided by 2. The graph of hyperbolic cosine looks like a hanging cable. So every time I think about hyperbolic cosine, I will be thinking about the Golden Gate Bridge. So hanging cable looks like the Golden Gate Bridge, and this is the sum of half of e to the x and half of e to the negative x. And then let's take a look at a function evaluation. So hyperbolic cosine of 0 is equals to 1 when x is equals to 0, y is equals to 1, and this is an even function. So even function, you can say that is y-axis symmetry. So cosine of negative x is equals to cosine of x. If you don't remember the difference between an even function and odd function, we can do a short review after this, but let's keep going. So even function, if you replace x with negative x, the x is gone. Another good example of even function is x squared. So x squared is another good example of even function. So if you change the x with negative x and then you work on the math, the negative sign will be gone. And then two more characteristics when x goes to infinity. So as x goes to infinity, so look at the red hanging cable. If you go all the way to the right, do we agree that the cosine approaches to the blue curve, which is half of e to the x? And then on the left side, as x goes to negative infinity, the hyperbolic cosine goes to half times e to the negative x, which is the green curve. So for the hanging cable, look all the way to the right. The cable is getting closer and closer to the blue curve, which is 1/2 e to the positive x. Look to your left side, as x goes to negative infinity, the hanging cable is getting closer and closer to the green curve, which is half times e to the negative x. So that is for hyperbolic cosine. For hyperbolic sine, so we have sine and then an h. The h stands for hyperbolic. So hyperbolic sine of x is equals to half e to the x minus half e to the negative x. So the difference between cosine and sine is for cosine you have a plus, for sine you have a minus. Of course, I am talking about hyperbolic, and then usually the textbook will just write hyperbolic sine of x, that is equals to e to the x minus, for sine, e to the negative x, and then divided by 2, and then here is the graph, and then there is a point that you should know when x is equals to 0, y is equals to 0, so we have a point at the origin, and then this is an odd function, so hyperbolic sine of negative x is equals to -1 times hyperbolic sine of x. Another good example of odd function, which is f of x equals to x to the third power. In fact, that looks like an x to the third power, right? I would usually for the x to the 1/3 power, they call this a parabola with a broken arm on the left side. And then as x approaches to infinity, hyperbolic sine goes to the blue function, which is 1/2 e to the x. So take a look at that. As x approaches to negative infinity, hyperbolic sine goes to the green curve, which is 1/2 times e to the negative x. And then if you subtract the blue and the green function, you get the graph of hyperbolic sine. So another words to describe odd function is origin symmetry. Okay, so origin symmetry, I will be thinking quadrant 1 and 3, quadrant 2 and 4. So that is origin symmetry. So let's do a brief review for odd and even function, so let me switch to a different color. So for even function, so let's say f of x, so this is a perfect example of even function. So this is an even function. Even function is y-axis symmetry, because if you replace x with negative x, so this becomes negative x square, right? So that is negative x times negative x, so the negative 1 times negative 1 becomes a positive 1, so you just prove that f of negative x equals to f of x. This is the characteristic of even function. And then for odd function, a perfect example would be f of x equals to x to the third. So this is an odd function. If you replace x with negative x, so you have negative x raised to the third power, then you have negative x times negative x times negative x, so that is equals to negative 1 times x to the third power, and then you just show that f of negative x equals to negative 1 times f of x. This is the characteristic of odd function, and which is what the hyperbolic sine is. Alright, so that is for the cosine and the sine. Let's go to the tangent. So for tangent, we have sine divided by cosine. So all you have to do is you just divide the function. Okay, so one for sine is a minus, cosine is a plus, and then you have this function divided by this function. The denominator 2 got cancelled, so you have a minus on top, a plus on the bottom, and then this is for hyperbolic tangent. Okay, so that's for hyperbolic tangent. And then for the fundamental identities of hyperbolic function, so let's recall the most memorable one for the trigonometric function, that is sine square x plus cosine square x equals to 1. I'm sure everybody remembers that. And then for how about for hyperbolic? For hyperbolic, is that still true? The answer is no. Hyperbolic function is a little bit different. So let's do a couple of examples. So let's take a look at the square of hyperbolic cosine and sine. So let's square the cosine and then divided by 2. So you square this, e to the x plus e to the negative x, and then divided by 2, and then square, and then you have e to the x, and then you plus e to the negative x, and then divided by 2, and then you multiply by itself, plus e to the negative x divided by 2. So this one, the denominator is a 4. The denominator is a 4. And then the numerator, you have ex times ex, that gives you x plus x, that is 2x. And then you have this, do you see that? And that, so this is a 1 plus 1. Do we agree? This is a 1 plus 1. Alright, so we have a 1 plus 1, and then e to the negative x minus x, that is e to the negative 2x, so plus e to the negative 2x, and then we hold on to that. You can change the plus 1 to a 2, but that doesn't make a big difference. And then how about the square of hyperbolic sine? So we have a sine hyperbolic x, this is a 2, and then you square, and then you have changed the plus to a minus. So this is a minus 2 square. You have the minus multiplied by itself. So multiplied by itself, what is the difference between the plus and the minus? So the difference between the plus and the minus is you have a 2 minus 1 in the middle. So you still have e to the 2x, but you have a minus 1, and then plus e to the negative 2x, and then you divide it by 4. So this one you have to subtract them. So once you subtract them, you can see some magic happens. I should say you can see some cancellation happens. So when you subtract hyperbolic cosine, these are cosine, right? I should write let's see. I should write this. So hyperbolic cosine, you can put the square right over here, minus hyperbolic sine. What is that equal to? So you have e to the okay. So e to the 2x plus 2 plus e to the minus 2x, and then divided by 4, minus e to the 2x minus 2, and then plus e to the negative 2x divided by 4. So since this is a minus, you have to be very careful. You have to distribute the minus sign. So overall, this one, all the e is gone. All the e's are gone. Do you see that? E to the 2x minus that, gone, right? This minus that, gone. So basically you have a 2 plus 2, which is equals to 4 over 4. That is equals to 1. So we just reached to our first fundamental identity. That is hyperbolic cosine minus hyperbolic sine equals to 1. So this is our fundamental identities. And then based on this, we can do a lot more. Actually, let's don't box this. So based on this, we can do a lot more. So what I am going to do next is I am going to copy this. So let's do a copy and then paste. And then I will divide both sides by hyperbolic cosine square. So how about this? I'm going to use a different color, and then I will just write I'm going to divide both sides by hyperbolic cosine square. So we have a cosine divided by cosine, I mean hyperbolic. So don't make me say the word hyperbolic over and over again. Cosine divided by cosine, we have a 1, right? And then sine divided by cosine, what is this? We have a tangent. So we have a tangent. Of course, everything is in hyperbolic. And then 1 divided by cosine is secant. I always forget the h. All right. And then what's next? Next, I am going to do the pasting again. I'm going to do the paste right over here. So this time, I will divide both sides by a sine square. So sine hyperbolic square x, and then sine hyperbolic square x. So cosine divided by sine, that is equals to cotangent. So we have a cotangent, of course, in hyperbolic square, and then sine divided by sine is equals to 1, and then 1 divided by sine is equals to a cosecant. So cosecant of, don't forget the hyperbolic, and then you do the square, and then you have x. So there we go. So here is your first fundamental identity. Second and third, they are not exactly the same compared to the regular trigonometric function. So we just introduced some fundamental identity. So how about this? We still have 3 more hyperbolic functions. How about the secant, cosecant, and cotangent? So for the secant, so let's switch to a different color. So for secant, CSC, hyperbolic, so secant is 1 divided by sine. So that is 1 divided by 1 divided by that. So what is sine equals to? So the sine is where is the sine? The sine is right over here, right? See that? The sine is right over here. 1 divided by that, you will be taking the reciprocal. So for secant, that is here, then that will be the reciprocal as well. So let's go ahead and then put it down. So for the sine, just look at your notebook, take the reciprocal of sine, then you have 2e to the x minus e to the negative x. For secant, that is 1 divided by cosine, of course hyperbolics, and the reciprocal of that, you change the minus to a plus, and then plus e to the negative x. And then for cotangent, that is 1 divided by tangent. So 1 divided by tangent is so 1 divided by tangent, then you are taking the reciprocal of this. So which is plus on top and then minus on the bottom. So plus on top, minus on the bottom. So we have e to the x plus e to the negative x, and then the minus is, just put the minus first, e to the negative x. All right, so that is for the cosecant, secant, and cotangent. And then that is the end of this brief introduction to hyperbolic function. If you like it, give me a like, share, and subscribe, and I will see you all in the next lesson for more exercise regarding hyperbolic function. So see you there.